We are looking to the CCS100 here. It's our new vapor phase inline machine with a multi-zone design for higher throughput. So we have a machine here with up to 5 workpiece carrier circulating, 1 process chamber in the middle, where we also introduce a new process technology. And this machine is meant for the industry of high volume, mid to high volume production, SMT production. So we can reach a takt time here, for example, a Euro format board of 15 seconds takt time. The machine has a quite slim footprint, so it's just 1 meter 80, 1,800 millimeters in the depth. In the length, it's 6,000 millimeters or 6 meter. And it's meant to reach high throughputs and for demands of short takt times. So here we see the loading sequence now. The board enters into the internal conveyor, and then a finger is pushing the board onto the carrier. The carrier has a size of 1,000 to 500 millimeter. Now for the show, we just load 1 board on the carrier. Usually it will be more, and the workpiece carrier is now lifted up and then transported into the process chamber. The board is now on the workpiece carrier. The gate to the process area will open and allow the carrier to move in. So the carrier with the PCBs is now entering into the process chamber. Process chamber is a stainless steel chamber with a process tank where the fluid, the Galden fluid, is captured and heated up. And the vapor will now preheat and heat up the boards to bring them to the peak temperature. And what we introduce here is a new technology, the vapor energy control, where the boards are staying in one position and the vapor is positioned in the height, and therefore creating different gradients, different thermal energy. It's very precise gradient control to realize different thermal profiles and to make sure the boards are heated up very effective and homogeneously to the peak and soldering temperature. And now the vapor will move down. The boards are now evaporating after the soldering, and then they will be transferred to the cooling zone. So the gate will open and allow the carrier to move into the cooling zone. The boards are now in the cooling area. It's a global bottom cooling, which is effectively cooling now the boards down. Now they are transferred to the unloading area, where a finger will unload the boards on an external conveyor, and then the carrier has been transported on the return transport back to the front of the machine to be loaded again. We now see the finger coming into position. It's now unloading the board after the soldering and cooling. An empty carrier will be then forwarded back to the front of the machine and allow again loading process.